Well, good morning, everybody, and thank you for this opportunity to present our project, Long-Term Large-Scale Freshwater Ecology. This project is co-led by me, Vicky Bell, and Steve Lofts, both of us are from UKCEH. So, as I know you're all aware, in the UK we have very high expectations of our rivers in terms of habitat, transport of water and nutrients, and of course recreation. The distance between ideal and reality has led to negative reports in the press, in the House of Commons, from the agency, and of course humorous cartoons. The impact on our rivers of projected future climate change, in terms of, for example, more intense rainfall, warmer temperatures, and coupled with rising population who require robust systems for food production and waste disposal, is still rather uncertain. However, the good news is that recent NERC-funded research provides us with new data sets, future scenarios, and modelling tools to explore UK freshwater futures numerically. And that's what we hope to do in LTLS Freshwater Ecology. So, as I said, we're building on recently developed modelling tools, and they enable us to simulate freshwater quality in UK rivers at the national scale. These were developed in a previous NERC-funded project, which explored how carbon, nitrogen and phosphorus in UK rivers has changed since 1800. Over this period, the UK landscape has been transformed by the growth of agriculture, by atmospheric pollution, and by human waste. As part of this project called LTLS, Long-Term Large Scale, we modelled how these changes contributed to the quality of our rivers over the last 200 years and at the national scale. And the image at the bottom right shows you the sort of outputs this work produced. And this work is now published. Oh, I wanted to add that following on from a question in the presentation, this sort of outputs also enable us to produce outputs that go into the marine environment, which can be quite helpful. So our new modelling project, LTLS-FE, aims to transform our understanding of freshwater futures for the whole of the UK. We'll use newly available climate and socio-economic scenarios to drive an innovative national scale model of the potential futures of all of the UK's rivers. We'll show how the combination of multiple contaminants and a changing climate might impact on our freshwater ecosystems. The research will identify catchments from regions most at threat from climate and contaminants. We aim to support policy development and ultimately protect the UK rivers. So this next slide summarises our project. Firstly, we've put together an experienced multidisciplinary team of scientists. Steve will tell you a bit more about that in the next slide. We'll explore future change by using recently developed scenarios of UK climate, that's RCP, and socio-economic, SSP projections. These provide a range of plausible and integrated future directions for the UK. We'll use existing studies and guidance from our stakeholders in determining the range of chemicals we're going to model. We'll use these along with advice and direction from our advisory board to generate driving data for our chemical and nutrient models. To meet the challenge of modelling multiple chemicals at the UK scale, we'll build upon the existing LTLS integrated model for nutrients, adding to it capabilities to simulate differing classes of chemicals as already prioritised. A key innovation is linking with the freshwater biodiversity models, national scale, which are based on existing national scale stressor and ecological data, for example, from regulatory agencies' data holdings. These models estimate chronic multiple stressor effects at national policy relevant scales and will estimate biodiversity changes under future scenarios. We'll disseminate the modelling outcomes in close consultation and collaboration with our stakeholders, using the outcomes as challenges to policy development for mitigation of and adaptation to the projected changes. We'll also make models and data fully available to the academic community for further use and development. And at this point, I'd like to switch to Steve.
Yes, good morning, everyone, and thank you, Vicky. So, as Vicky has said, we've put together an experienced multidisciplinary team to tackle the project objectives that we've set ourselves. You can see the list here. We have people from UKCEH, of course, Arthur Rossenstead Research, the British Geological Survey, Cardiff University, and Boburn Consultancy. And together, they provide cross-sectoral expertise going across hydrology, agriculture, ecology, geology, chemistry and biogeochemistry, modeling and software development. And importantly, many members of the team have worked together on previous projects, such as the LTLS project, but also the Assist National Capability project. So people already know each other and know how to work together. Very importantly, we have also put together a stakeholder advisory board. Now, this comprises members of UK government departments such as DEFRA and regulatory bodies such as the EA, SEPA, Natural Resources Wales, and the Northern Ireland Environment Agency, pardon me. The water industry via UCWI, the Coal Authority, and other statutory bodies such as Natural England, also the National Trust. We are looking to expand the stakeholder advisory board. We are looking at talking to, for example, Rivers Trusts and the National Farmers Union about bringing people on board there as well. So if you're interested, please do get in touch with us. Next slide, please. So what are the key freshwater quality challenges that we want to address in this work? Well, we want to identify key chemical and nutrient stressors. This is something that we do need to do at an early stage of the project in order to focus our model development work and our scenario development on the specific numbers of chemicals. So we will be developing a list of chemicals that we will be modeling along with our stakeholders, so both reflecting scientific possibilities and the interests and concerns of our stakeholders. We need to provide useful, plausible and coherent future scenarios to use in our work. As Vicky has already mentioned, we will be using combinations of socio-economic scenarios, the SSPs, and climate change scenarios, RCPs. And we are very lucky that recent work within UKCH has developed both types of scenario for the UK context. What we will do with this in this project, in close consultation with and taking expert advice from our stakeholders, is to develop from those scenarios future projections of chemical use and chemical inputs into the UK freshwater environment to drive our modelling of freshwater quality and ecological quality ultimately. And really that's where robust integrated simulation of chemicals and nutrients in freshwaters is going to come from. We already have a firm base. We have the LTLS integrated model, which simulates nitrogen and phosphorus in UK freshwaters. We will add chemicals such as metals, pesticides, PFAS, etc. into that. And we will then build upon that to simulate the ecological effects due to those multiple physical and chemical stresses. So at that point, we bring in the climate change scenarios and variables such as water temperature into the equation in order to make projections of the combined effects of these stresses. And finally, and a very important part of the project, is useful dissemination of outputs to stakeholders for policy and scientific purposes. Now, our future scenarios operate at quite a high socioeconomic level. They present a variety of what are usually called stories or storylines about potential future socioeconomic directions for the UK. And we take those as a starting point and work right through to what the implications are for freshwater chemical and ecological quality. And because we're doing that, we can link the predicted effects of our models right back to socioeconomic and policy drivers. And we can use those with our stakeholders to then encourage them to think about the policy options that could be used to tackle the issues that are projected to occur over the next few decades under each scenario. Next slide, please. Sorry. So the project structure is as follows. We have 3 work packages. Work package 1 tackles the prioritization of the pollutants that we are going to simulate in our work, the generation of the chemical input data sets that will drive our modeling, in other words, our consultation with stakeholders on how our scenarios and their differences, how that will drive how chemical inputs to UK freshwaters would change over the next decade under each putative scenario, and the development of terrestrial models for release of chemicals and nutrients to freshwaters. The potential importance of soil as a pathway to freshwaters has already been mentioned, and we certainly take that into account in our modelling, as our modelling is integrated modelling of soil and freshwaters. Work package 2 is then the modelling of the transformation, transport and fate of nutrients and chemicals in rivers, taking into account projected hydrological changes under our different scenarios, and the modelling of those multiple stressor effects at national policy relevant scales, and the forecasting of biodiversity changes under our future scenarios. And then work package 3 is very much concerned with dissemination. So it's our work with stakeholders to use the outcomes of our scenario modelling to support long-term policy and planning, and our making those outputs, our model code, the data sets that we use to drive the model, fully available for use in follow-on projects, including the incorporation of our models into an open source framework for the research community. And then website and web dissemination tools to enable interested parties to explore our results and what they mean for freshwater futures. Next slide, please. So to summarize our aims, the project aims to be the first to use these novel, integrated and coherent scenarios of alternative UK futures to generate these trends in chemical inputs to freshwaters. We aim to produce the first forecast of changes to river chemistry and ecosystems at a national scale, accounting for multiple stressors and how they change in terms of their patterns and their complexity. By doing this, we want to get unprecedented insights into how those multiple stressor impacts on river systems over the long term. And we want to use that to be able to produce distinctive, useful and usable outcomes, both for science, for policy and for society, with continuous involvement of our stakeholders. Next slide, please. And with that, we'll say thank you very much for listening.